So for our problem here, they're asking us to integrate. So the first step to integrate is to separate every term. So what we're gonna do is separate every term like this. So now that you have separated every term, you can now integrate. So to integrate, you have to do this. You have to do the formula that is 6x2 plus 1 divided by 2 plus 1. So because this you have to put it here. Now minus 15x 3 halves plus 1 divided by 3 halves plus 1 minus 6, so you have to bring this up here, so x minus 2, and the 7 you just have to put the x, so it's 7x. So now that you have this, the answer will be 6x to the third divided by 3. This one will be 15x 5 halves divided by 5 halves minus 6, and here I forgot, you have to put this one the same in here, so it's minus 2 plus 1 here, so x will be minus 1, and in the bottom it will be minus 1 minus 7x. And another important point here is you have to put a c since you're already integrating. And since you already finished this step, you have to put the c. After this, you have to simplify all this. So what you're gonna do is 2x cubic minus this. You have to do the formula, so the answer will be 9x divided by 9x 5 halves minus 6 divided by x minus 7x plus c. You can now simplify this also, so the correct answer would be 2x cubic minus 9, so you have here 3x minus 6 over x minus 7x plus c, and this is your final answer.
In this problem, it asks the probability it is not J, Q, K, nor an ace when randomly select the cards from a standard deck. So what we first need to do is to get our sample space. This is a D because D stands for sample space, and it is 52. Why? Because a standard deck of cards has 52 cards. That's a little obvious. Now what we need to, after this, we need to find what they ask us, what the problem asks us, which is the probability it is not J, Q, K, nor an ace. So what we need to do is first look for the answer, probability of J, Q, K, sorry about my Q, and ace. But it says the probability it is not none of this. So we need to put this sign, or a straight line, whatever you want to call it, because this means the opposite of this. So after that, our answer, is pretty simple. It will be a fraction at the denominator goes the sample space, which is 52, and at that numerator we need to put the difference of this, which means it's 52 minus all the cards that are all these cards that are on the deck. We all know that in a standard deck we have 4 of these, 4 of these, 4 of these, and 4 of these. So we just multiply 4 times 4, which is 16, and that's our subtraction. 52 minus 16, which is 36. So that's our answer. But we are not done yet, because we need to simplify it. And the simplest form of this is 9 over 13. And now this is our answer.
Here for question 23, it says 2 cards are drawn from a standard deck of cards, one at a time, replacing the first one. The question A says, what is the probability of selecting an ace of hearts, then a black queen? The probability of selecting an ace of hearts is 1 in 52. And the probability of a black queen is 2 in 52. You multiply these two, and it gives you 1 in 1,352. And that's the answer. Then for question B, it says, what is the probability of selecting a black queen, then an ace of hearts? So basically you get the probability of a black queen, that it's 2 in 52. Then the probability of ace of hearts, it's 1 in 52. And again, you multiply them, and it equals to 1 in 1,352. And that's your answer. And for the last question, letter C, what is the probability of having selected a black queen and an ace of hearts? So then you're going to use the formula. And it says the probability of black queen, it's 2 out of 52, times the probability of an ace, that it's 1 in 52, plus the probability of an ace times the probability of a black queen. And it's equal to 1 out of 676. And that's your complete worksheet.